first session, and we are going to talk about SOA suite in general, and we are going to get in detail about SOA and what is a service, what is the definition of a service. People who have attended the intro session we did 2 days ago, um, I would request them to kindly indulge me for some time during the session, because some of the things might be repetitive from the intro session for the benefit of people who have joined in today. So if there are any questions, anything in between, you can always just chip in and kindly unmute yourself, and you can ask me any questions. Now, what do we have as an agenda for day one? We'll give a overview of SOA. What is SOA and how we are going to use it. We are going to define it and what consists of SOA, what actually makes up SOA. We are going to define a service in general and try to understand how it ties up into SOA suite, which is service-oriented architecture. We'll have a SCA overview, which is a component architecture, which is a guideline, a specification which is given. So we'll talk more about that. We'll talk about the elements of SCA, which help tie up into SOA. We are going to look at standards which enable SOA, how a SOA is prescribed and it is built. And at the end, we're going to have a look at the Oracle SOA suite architecture in general and move ahead, end the day with that information. Now, let me take a moment and just talk a little bit about what is an integration scenario, a normal integration scenario. This is pre-SOA world. In general, for any business which is being done online, you would in general have a customer who would go to the website and purchase something, and that goes to that request goes to the web server, which in turn initiates a workflow or a business process in the background. Now, that business process in a particular organization could connect with multiple internal applications to execute each step. So, for example, a validate order could go into one of these internal applications like Siebel or SAP, and it could go and validate the order at that point. There could be a check credit, which is an external application. It could be a third-party provider who might be doing credit checks for us. It could go into the inventory. If it is a third-party provider, then the parts could be checked on a third-party basis as well. And similarly, the other steps which are related to billing or related to the shipping. So all these steps are executed with one application or the other, because an enterprise doesn't completely need not necessarily run with one full application. It might have multiple applications for each of their specific needs. So what happens is tying up these applications becomes a very manual job or a very tedious job, because each one you have to specifically write a program for it, write an interaction for it, and if in case there is any change on any one of the applications, then your whole overall workflow gets affected, and that could in turn cause a delay for the customer, which is not the best thing to happen to a business. So, and also the third-party providers, a lot of times because they're outside your organization, you do not have a control over the response times. You do not have a control over a lot of aspects of their working as well. So there also comes a manual delay which could be happening, and this overall could create a problem for the business process, right? And in turn affects the delivery. Now, so just to have a look at there are multiple applications. So if any one of these applications is changed, even that could cause a problem. That could be an issue. Because say you have written something specific to connect to Siebel and work with Siebel. Tomorrow, if you want to change it to say another cloud CRM or something, then you will have to write a specific process or specific program to be able to connect to the cloud CRM, and that might cause a problem because your process will get stopped. That's one of the major issues that you might have. There are long cycle times with manual process. So as I mentioned, you do not have control over your third parties. They could cause any manual delay, which could cause more delays in your internal process. And there is collaboration with partners is very limited. So the third party providers might not be working on the same pace, or might not be working on the same on the same understanding as yours, right? As your business process needs. Although you want them to, but there might be some delays. And also, you can't change the third party provider. It's about decoupling them. Right now, they are very tightly coupled. If you want to change them, then it is a very big overhead for you, because tomorrow another logistics provider might have a different way of connecting with them, and you will be again redefining the connection. So that is a big major delay. Now, how does that? So the traditional integration, how it solves it is it goes for the normal solution was a point-to-point custom code. So here all the applications, as we saw in our previous slide, are interconnected using custom code, and they follow, say, proprietary messages and APIs. They have custom integration links. So each one talks to the other application. So this becomes a very big mesh. There is a lot of duplication of effort the way. So today, if I'm connecting to Siebel, PeopleSoft to Siebel, then I'm connecting legacy to Siebel. So there are two connections coming in. This is somewhat looking like a duplication of effort connecting into Siebel, or similarly to other applications. There is lack of open standards. So for sure, you are following the standard prescribed by the particular application for connectivity. So Siebel might be using a data bean to connect with it, or a web service. SAP might be using a BAPI to connect with it. Internet might be following a JSON format as an input message payload. And a legacy application could be a database application which works only with procedure calls. So something like that, wherein you're not following a single open standard to connect with each of the applications throughout your organization. There is tight coupling of data and implementation. So obviously, if SAP to Siebel connectivity is there, then that's very specific to SAP to Siebel or Siebel to SAP. And any one of those changes, then you are stuck. Once a new application comes on either side, then you are having to change your definition for that, and you'll have to make sure that the program again has to be rewritten to connect. There's a skill set issue. You need specific Siebel resources to be able to work with Siebel. You need specific SAP resources to work with SAP, so that you can fully utilize the connectivity. The project lasts months, right? Because of so many point-to-point connections, you are having to write a lot of code, and you are having to generate a lot of artifacts. The cost is high indirectly, or rather directly. The operation policies are for each application. So each application will have its own set of policies of what is accessible and what is not, what is supported as a transaction, what is not. So that makes it difficult, because you have to apply a policy at each application. You have to go to SAP to apply a policy. You have to go to Siebel to apply a policy. So that causes a lot of issues. You are having to maintain multiple copies of a similar organizational policy. Lack of agility, of course, because you cannot change the applications on the fly. You are not free to change the definitions. You are not free to add more as you want. Your business is quite restricted in that way. And slow response of IT to business. So obviously the IT wouldn't be able to catch up with the way the business flows. Today there might be a very important need for the business to immediately change, but the IT might give out its own timeline, and that slows down the overall business. Now, in order to solve this, we have the service-oriented architecture. Now, let me just take a step back and just go through the definition of this service-oriented architecture. So it's an architectural style that supports loosely coupled services to enable business flexibility in an interoperable, technology agnostic manner. SOA consists of a composite set of business aligned services that support a flexible and dynamically reconfigurable end-to-end business process realization using interface-based service descriptions. Now, at a high level, if I just read through this, it might sound complicated, but if we break it down into those important words which actually give out the essence of what service-oriented architecture is and what SOA signifies. So the first point is a loosely coupled service. So what SOA prescribes is that when you are adopting the SOA nature for your services or for your organization, then all your services which you develop should be loosely coupled. When we say loosely coupled, it means the request, the services in question, the caller and the callee, they needn't be aware of how they are implemented, and they needn't be aware of where they sit. So, for example, from our previous slide, connectivity between Siebel and SAP should be very generic. It should be as per business. It shouldn't be a Siebel to SAP connectivity, but it should be more of a query order or update order or some functionality, so that tomorrow if SAP were to change, then to Siebel it doesn't matter that it was SAP at the other end, but it was an application which was supposed to do a particular function, and if that app changes, it doesn't make any change to Siebel. It only means that it's easily replaceable. Similar thing on Siebel as well, right? So SAP will not know what is the calling application, and it doesn't matter if it changes. So that is one of the ways of calling it loosely coupled. So SOA prescribes that your services should be implemented loosely coupled. Interoperable. That is, it doesn't matter what kind of a definition or what is the platform on which it is defined. So again, SAP might be running, or your legacy application might be running on a different platform, and your Siebel is running on a different platform. The way the services are implemented is different. So when you want to call any service, you needn't know how the implementation is. It could be Java, it could be .NET, it could be C++. It could be very specific to the best possible way of achieving the goal of that service, the business goal, the functional goal. So the service should be interoperable. When you call it, it can change from Java to C++ to any other technology, and the calling service needn't have any problem. So the functional consistency is intact. Composite set of business aligned services. Now, business aligned is very important, because what SOA prescribes is that you do not create a service or a functional service, or a service for that matter, just for the sake of creating a service. You create it for a particular business need. You create it for a particular functional need, and that should be the definition of your service. So, for example, in our if you see in this diagram, you have a service called Get Customer, which fulfills a business need, a particular functional need. You have Get Product, which is a business need. You have Place Order, Get Container. So all these are services which are fulfilling some need. So your definition of a service, what IT defines, should be of that nature. And the last one is the service descriptions. Now, this is very important, because it enables you to reuse the service as well. So what I mean by service description is, if today it's Get Customer, then anywhere in the organization, so today, say a IVR system is calling out Get Customer, tomorrow another system might want to call Get Customer. So Get Customer would have a service description which is generic enough, or which is easy enough for any system to understand and know that, okay, Get Customer needs input as an ID, and the output will be a customer detail. The service is deployed at this location, so I need to call out at this location. That will be the service location, the binding which is given, and it will describe how the input should be sent, right? Is it an XML or a JSON, or how does it? So it would prescribe you. So mainly we deal with XMLs. So it would prescribe to you how the services can be accessed or connected to. So that is the service description, and it has to be placed for each of these services so that they are reusable, and tomorrow anyone can come and call them and understand. So that is one. So the deeper meaning for this service description is also there is also service discovery, which is which is done by something called as a UDDI. We'll look at that a little later, but for now this is the definition of SOA. So any questions till now about what is SOA and what is being done? Okay, so if there are no questions, I'll just move forward. So if you have any questions, please do unmute yourself and you can ask me a question. Now, what are the benefits that we get with this if we were to adapt the SOA nature or the SOA, the service-oriented architecture? So what it does is it gives you, it first of all masks the underlying technical complexity. You do not know how complex your implementation for a service is. So as per our example, if we were to just say get customer, we don't know how many, what is the type of implementation, what are the checks it's doing before it returns back a customer detail to us. So we do not know the complexity. So all the services, when they're implemented like that, then the underlying organizational complexity is covered, and it is not shown. There is a faster business response time. So obviously then when the services are reusable, when they are loosely coupled, then it's easier for you to shift from one to other. And if the definition is constant throughout, then your change of implementation will not affect the overall process. So that's why your business response time increases. It improves business agility. So your business can grow faster with any change, and there won't be any problem. It aligns IT with business. So today IT and business can talk the same language. The services are implemented in the way business understands it. So today IT will not come and tell you a more technical jargon of a get customer or a get order or a put order, and business will understand what you're talking about. So what are the benefits you get with all this? You get reusability, services are reusable, interoperability, services can be implemented in any way, it doesn't matter. Scalability, so today your create order or a put order might be able to take say 1,000 orders per system, and because you have given a service description, you can actually use a proxy and make sure that any number of systems, any number of implementations or servers which cater to create order can be kept behind the proxy, and you can scale the system very quickly. There is cost efficiency. Of course, when you are reusing services, when you are implementing services, there is a cost efficiency to it. You are able to do more with the current set, and you don't have to redevelop things. So there's definitely a cost efficiency there. Now, coming into so we've been talking a lot about service oriented architecture, and so what is a typical implementation, right, of services? Like how are our processes actually implemented when we keep saying services? We'll go to the service definition, but before that, we'll just have a look at what are the implementations. So typically, you have point-to-point implementation, which is a proprietary implementation we saw. There are vendor-specific implementations, which are, say, using technology like Tuxedo, which enables this integration with a consistent approach. So it's not that SOA just came out of the blue. There has been a constant direction which has been developed with multiple various options, and which has led us to this. There is a very famous common object request broker architecture, CORBA, which was used for quite some time. Although it requires more programming, but it helps you in getting the integrations done in a more consistent way. But due to the higher programming intensive programming need, the implementation costs are very high. So that kind of reduces the usage, but it is an architecture nonetheless, which has been accepted and used for quite some time. And now we are talking about web service and SCA style implementations. It uses all open standards. It uses the web standards, and it uses XML to work with. So we'll go deeper into this aspect of web service and SCA, which is more relevant to us because it follows all the SOA principles, and it follows something that we are trying to do to the core. So what is in essence a service? So what are we talking about with service? So service is basically a building block for a SOA application. So when we say that our application is SOA enabled, then there can be a single or multiple services which come together to create that application, right? Like we see in this, your service could be interacting with multiple services internally and coming back with a final response to the client. So it has a the standard interface, and it would have a message structure which is defined. It is accessed using standard protocols. So in our case, it could be the SOAP over HTTP. We'll talk about that little later. So it is basically, that is where our definition of service is. This is our use of service which we are looking at. So here we can see that we are defining the language using a standard service description, which is a WSDL file, and the request message is an XST. It's defined in an XST, and the other services will also similarly have WSDL and a response as well, which is XML based. Now, coming to service component architecture. Now, it is a set of specification that defines an assembly model for a composite service. Now, till now we were looking at service-oriented architecture, which was an architectural definition, or it was a way we needed to specify our services and how we can implement an application. But service component architecture is a spec which is given, which enables you to implement SOA. So there is a slight difference here. SOA is the architectural base which is given, but SCA is the specification which is given in order for you to easily implement SOA. So that's the big difference here. So that's why we are looking at SCA. Now SCA is heavily used for the Oracle SOA suite products from 11Z. So in 12C also it carries forward the same set. And we are just going to look at SCA with the understanding that this is how our components are defined. So this will give you an idea of how the components are defined. Now, service component architecture, it's an assembly model for a composite service. So a composite service in definition is multiple smaller services assembled together to be able to give you. So in our previous slide, we read that an application could be a combination of multiple services. So a composite services, it's a combination of multiple smaller components which are provided. It provides a programming model for building applications and systems based on SOA approach. So it will follow the SOA approach, and it will help us in developing these applications. It extends and complements existing approaches to implementing services. So it will reuse the existing definitions, the way the services are implemented. It would extend on that. That is, you can use any one of the implementation techniques, and you will be able to follow the service component architecture and be able to implement your SOA application. It provides a model for composition of services. So it describes that that each service should be broken down into smaller components, and each application should be actually smaller services. Creation of new services and reuse of existing systems. So if there are any existing systems defined, then how do you convert them into services, and how do we reuse if they already have any services? That is also specified. And it builds on the web services and other open standards. So this is very common to what we are looking with our service definition, what we needed for a service. Now, what are the main elements of a SCA? So elements of SCA are, first off is the assembly model. So this is a set of composite services combined to form the application. So first off, it says you need to have an assembly model for your application. You should know what are the components of your application, and that will be your assembly model. Implementation and language spec. So you should have some specification by which you are going to implement these components or implement this service. So in our case, we are going to be using BEPL and Mediator. It could be Java, it could be .NET as well. So SCA is quite open in that way. Because it's a specification, you can use it for any language. Infrastructure specification. So you should have a standard policy framework to control transactionality, security, and reliable messaging. Now, we'll be talking more about this later, but from a theory perspective of SCA, the understanding is that any service which is using, which is SOA based, we have implemented with SOA principles, and we have used the SCA specification to do it, then it should have these four categories which need to be satisfied, and one of them is an infrastructure category, wherein what it defines is your services should be following a policy framework. They should be having a policy for transactionality, security, and reliable messaging. So you should be able to control your service via policy, and that is important. So then you are adopting the SCA specification. The access method spec, that is the types of binding. So your service should have various types of bindings. It should not be stuck on just a SOAP binding. It should have multiple bindings as well in your services. So you should have bindings basically. So that is the access method specification. Any questions on SOA or SCA till now? Okay, I'll carry on then. Now, what are the standards that enable SOA? So we have been talking a lot about SOA and the implementation that is done by SCA. So what are the actual standards that actually enable SOA in general, right? The definition. So there has to be a WS policy, there has to be a web service policy, web service security. So this comes on the management layer. You are supposed to, so for the assembly model, we have SCA, which specifies the specification. So for data access, there is a service data object. Now this service data object, I want to just talk a little bit about it. So this service data object is basically defined for abstracting your data layer. So you are able to access data resources using a service data object, and this definition actually, so this would abstract that layer and give you a way of accessing your data without knowing the actual source of it. And this is mainly used with ADF. So in SOA, when we talk about a greater Oracle stack, you have ADF backend components, which is not the scope of our implementation, but the data objects are used. So that is one definition of a data object. So we don't create specific SDOs for accessing data. We'll have another way of doing it. So this is also a layer which enables SOA in a way. So that is for data access. There is business processes. So the business processes are enabled using the BEPL 4WS. So there is a web services standard for business process execution language. So BEPL is implemented. There is WS reliable messaging and security to make sure there is quality of service. There is UDDI for the discovery. There is WSDL for the description of the service. What does a service actually do? For messaging, you have SOAP and XML. So you would have XML as the standard format, and SOAP is your protocol. So we'll talk more about SOAP later, that is in tomorrow's session. So we'll go in detail with SOAP, WSDL, XML in the coming sessions. The transport layer, which could be HTTPS and IOOP, JMS, SMTP. So all of these actually support a SOAP, carrying SOAP over their layer. So we'll talk in detail about this later on. Now, coming to the big Oracle SOA suite architecture, what does SOA suite actually offer? And if we compare with what we have been seeing till now, the definition of SOA, the definition of SCA service. So what does it have? It has multiple components as per the SCA specification. It has BEPL, it has business rules, it has mediator, human workflow. So all of these are the components which will help us to build a service. It has a unified runtime. So what SOA suite from 11G onwards has done, and it carries forward in 12C, is that they have created these components which individually would create a composite which together would create a composite application. Individually, they are standalone. Individually, there are standalone systems which can also. So, was there a question here? Okay, I thought there was a question. Individually, these components can also carry a service, but with BEPL specifically, which takes care of the orchestration and which takes care of making sure that we are able to call out the services that we want in a proper orchestrated manner. There is business rules which helps in creating rules and tries to it helps us to externalize our logic. There is mediator for the routing. So these components and the human workflow for enabling approvals, and you'll have a workflow which will identify approvers, and you'll be able to get workflows completed. So that is so on the SOA suite architecture, these are some of the components. You have an external BAM which helps us in generating reports for this for any application that we are running. So it will generate reports for that based on our configuration. You have a EM console to manage it. So as per our SOA standards, if you remember, we should be able to monitor and manage as well. And there is all this is underlying. You are able to have connectivity to the Oracle database and any other application which is not native. And you also have the Oracle Service Bus, which helps us in virtualization. There is a common JCA connectivity infrastructure. Now, this is something which comes in at the adapter layer. So adapters we'll see more in coming sessions are basically connectivity links which are given for be able to connect to any specific application. So you could create an adapter, and these components like the mediator or the BEPL can use that to connect to any of the applications. The Oracle Service Bus is mainly used for virtualization of a service. So what that means is that today your service could be deployed on say server ABC, but to an external client you can give server XYZ. Now XYZ is where you would deploy a service bus, and that service bus would be connecting to your internal services. That is partly what virtualization is. We'll talk more about it when we go through Oracle Service Bus in the coming days. So this is what Oracle SOA suite has as an architecture. Any questions on this? Sorry. Okay. If not, I'll just move forward. So the different components, the Oracle SOA components, just now we saw the architecture. The different components are one is for the analytics. You have business activity monitoring and event processing. wherein it can help you collect data regarding your service and regarding the usage pattern of the services. There is the orchestration, which is done via BEPL Process Manager, and business rules helps in externalizing your rules. The service virtualization mediation is done by service bus. As I was mentioning, it helps you in not just virtualizing your service, hiding your service, but also making sure that the external party is abstracted. So as I mentioned today, it is on your server is deployed on ABC, and the customer is given XYZ where your service bus actually resides. Now the service bus knows that your application is deployed on ABC, but the customer wouldn't know about it. Tomorrow, if you were to change it to another server, say dev1, then all you need to do is go change the definition in the service bus in the background, and the customer will never know. They will always be calling XYZ. So there you are not just making sure your service hides, but you are also making sure the connectivity never breaks. So virtualization helps in that, and it also does the mediation. For connectivity, for Oracle SOA, we have with 12c a lot of cloud connectivity which has come in. As we know, Oracle has been targeting the cloud space for quite some time, and with SOA 12c, they are looking at a lot of these cloud adapters to be able to connect with cloud applications. The way the adapters work, and which we will see coming forward, is it simplifies the way you connect with an application, because it's already predefined, and it's with a step-by-step wizard framework, it's easier. So when we use adapters, it will give you a better picture in the coming sessions. The connectivity-wise, you have on-premise apps, mainframe, DB. There is direct connectivity. So all of this is done by adapter. For B2B also, business to business, there is an adapter which can be used and which will enable for EDI and XML based transactions. For our current 12c implementation, we are not looking at B2B. We are looking and we will be touching upon MFT at the end of our sessions. Now, these are some of the related technologies, and these are some things that we will take up in the session tomorrow when we start off with getting into detail with SOA suite and SOA architecture and how it is implemented. So we are going into detail, and we are going to get more in depth into XML, XSD, WSDL, SOAP, JCA, and a lot of other stuff that we are going to talk about. So I think you can find the content, course content at the training page, and we'll be following that, and we'll be going ahead with our sessions. So so today that's all about it that I wanted to discuss for today. Are there any questions?